Hi, this is Calandra. In this video, we will cover graphing equations by plotting points and determining if a point lies on the graph of an equation. So to graph an equation, we can plot points. The more points that you graph, the more accurate your graph will look. So for this example, we want to graph the following equations by plotting points. The first step you may want to follow is to get one of your variables isolated on one side of the equation. So for this particular equation, it would be easy to isolate the y by dividing both sides by 2. So we end up with y is equal to x cubed divided by 2. And now what we want to do is create a table of values, sometimes called a t-chart, and we'll have our x in one column and our y in the other column, so you can see how the chart is forming a T. And now, if I plug in values for x, I can easily determine what y is equal to. So one of the easiest values that we can start off with is 0. So when x is equal to 0, y will equal 0 cubed divided by 2, which is just 0. So we end up with the point 0, 0 on our graph. Next, I'm going to pick x equal to 1. So y, according to our equation, will be 1 cubed divided by 2, which is just 1 over 2. So we now have our point, always written as x comma y, 1 comma 1/2. We can always also use our negative values, so let's say we put in a -1 for x. Then y will equal a -1 cubed divided by 2. -1 cubed means -1 times -1 times -1, which will just be a -1 over 2. So our coordinate will be -1 comma -1/2. Let's do 2 more points. If I use an x value of 2, y will equal 2 cubed divided by 2. So that's 8 over 2, which is equal to 4. So we have the point 2, 4. And then lastly, we can do our value of -2. So if we substitute -2 in for x, we'll have -2 cubed divided by 2, which is -8 divided by 2, or -4. So we have the coordinate -2 comma -4. All right, so let's see if we have enough points here to determine which of those 4 graphs represent this equation. So I know that 0, 0 is on the graph of our equation. So if I look at graphs A and B, it looks like 0, 0 does lie on those graphs, so we cannot rule them out. For part C, 0, 0 is not on that line, so C cannot be the graph of our equation. Similarly, 0, 0, one of our points, is not on the graph in part D, so we can rule that graph out as well. So now let's move on to our other points. I have the point 1, 1/2. So let's see, 1, 1/2 is going to be somewhere in here. So this looks like a possibility. For my second graph, 1, 1/2, it's going to be a little bit above the x-axis. It looks like I don't have a point on my graph there, but it's a little bit ambiguous. I can't tell because the graph is not that sharp. So I wouldn't rule it out just yet. So let's jump down to our point 2, 4. Well, if I look at my x value of 2, the y value of 4, I see that that is on the graph for A. If I look at 2, 4, that point clearly is not on the graph of B. So I can rule that out. And we only have one option left. So A would have to be the graph. So if you had looked at where -1, -1/2 is located, that too may have been a little bit ambiguous, which is why I jumped down to the 2, 4. So you just keep going until you can rule out all graphs except for one. Okay, for our equation in part B, again, our first step can be to get one of the variables by themselves. So for this case, it would be easiest to get x by itself, so we don't have to deal with that exponent. So I'm going to subtract y squared to the other side, and then divide both sides by 3. So I have x is equal to a negative y squared divided by 3. So when I do my t-chart, we always keep our x first because when you're graphing it's always x comma y. But notice for this particular equation, it's going to be easier to substitute values in for y and figure out what the corresponding x is. So let's start off with a y value of 0. When I plug in y equal to 0, I'm going to have negative 0 squared divided by 3, which is equal to 0. So I know that I have the point 0, 0 on this graph. Okay, so let's kind of examine our graphs as we go along. Okay, we have the point 0, 0. And so we can rule out A, because that does not have the point 0, 0. B is a little bit ambiguous, so we can't rule that one out yet. C, that looks like it may be on that graph. But for D, we see 0, 0 is not on that graph, so we can rule out D. Okay, so now for the graphs that we have, notice that the x values that are represented are negative. So in my table of values, I'm going to pick negative values for x so that I can figure out the corresponding y values. Okay, but actually, we are substituting in numbers for y because we have x isolated. So for this top graph, it looks like we have positive y values. For this one down here, it looks like we have negative y values. So we want to take both of those into consideration. So let's start off with a y value of, let's say, positive 1. When I plug that in, I get a negative 1 squared over 3, which is negative 1/3. So we have the point negative 1/3, comma 1. Okay, so negative 1/3, comma 1 looks like it's located on both of our graphs, so we can't rule anything out yet. So why don't we next try a y value of negative 1. Notice the graph in part B doesn't have any negative y values, but the graph in part C does. So let's see what happens if we plug in negative 1 for y. Well, we end up with negative, and then we're squaring the negative 1 divided by 3. So we have the negative on the outside. When you square negative 1, it gives you a positive 1. So that gives us negative 1/3, comma, negative 1. So if I look on my graph, negative 1/3, comma, negative 1 is represented on the graph of C. Notice there is no negative y value represented on the graph in B, so we have to reject it. So answer C would be the graph for our equation.